The radio frequency amplifier circuit, we've got a positive supply. This is just a stabilizing capacitor to ensure a constant voltage supply across the circuit. The circuit has L2 and C2 over here that operates as part of a tank circuit to determine the operating frequency that this amplifier will operate at. That allows for only a certain frequency range to be amplified. The Q factor is determined by C2, L2, the transistor and R5C4 combination. The circuit is biased according to the collective feedback biasing through L2, C3, R2, R3, L1 and R4. Serves as the biasing for the transistor. Now at low frequencies, this inductor will have a low reactance, so it is effectively removed from the circuit, but that capacitor will have a high reactance, so it will have that as a high impedance circuit, which will allow for gain at low frequencies. When we get to higher frequencies, the capacitor there serves as a bypass condenser, which means its reactance becomes very low, so current's rather going to flow through the capacitor than through the resistor. Conversely, the inductor will develop a very high reactance, and that allows for the gain at high frequencies to be determined by L1 and R3, along with the biasing of R4. Capacitor out and capacitor in are just connecting or coupling capacitors, which blocks DC from entering or leaving the system. How it operates: this capacitor and this inductor will constantly charge and discharge and transfer energy between them. As they transfer the energy between them, they will allow this transistor to switch on and off at that frequency determined by the tank circuit. When an input signal is received that is synchronized with that operating frequency, what happens or what occurs is we will have that input further biasing the transistor, which in turn will allow it to turn more on or more off, and that way we will allow for amplification to take place and the output signal to be received. So if my input signal is at the right frequency and I put that signal, a small sine wave in, the biasing of the charging of this capacitor will bias the transistor, which in turn will turn that transistor more off. Remember, the gain is determined by the collector biasing as well as the transistor's value. When I decrease the input value, the biasing on this capacitor will bias this transistor, and as this voltage decreases, the transistor turns more off, which in turn will turn the voltage more on. Now, because of the tank circuit L2 and C2, this circuit will operate at a set frequency. Because of the impedance in the rest of the circuit and the resistance in the rest of the circuit, namely R5, and the impedance of the transistor, we will get a Q factor that is determined. Now looking at the frequency response, that there is my gain at 0 decibels. And then we've got our half power at -3 decibel. So it's about there. And we will see that it cuts the graph at those 2 points, which means this there is my low frequency, and that point there is my high frequency. Over my frequency ranges. My resonant frequency for the tank circuit occurs directly in the middle over there. Frequency response is very narrow because of the tank circuit and the resonant frequency of the tank circuit. All the frequencies that fall between my lower frequency and my high frequency, that is considered the bandwidth at which this amplifier will operate. The gain calculations are the same as those that we've looked at in the past.